Hello friends, dear learners and my dear student. First of all, I take an opportunity to welcome you on the lecture Ultraviolet Visible Spectrophotometry. Student, I am Dr. S.R. Labhade, working as an associate professor in Department of Chemistry. Student, in previous lecture we discussed the terminology related to electromagnetic radiation. We discussed the properties of wave related to wavelength, wave number, amplitude, frequency and velocity of the wave. In today's lecture, we discuss the terminology related with absorption spectroscopy. We know that spectroscopy is the branch of science that deals with qualitative and quantitative analysis of sample via its interaction with electromagnetic radiation. Therefore, based on the radiant power absorbed or emitted by the molecular and atomic species, the spectroscopy can be classified as number one is a absorption spectroscopy. In absorption spectroscopy, when sample is irradiated with electromagnetic radiation, sample absorbs electromagnetic radiation at specific wavelength. At other wavelength, that substance is transparent. The wavelength at which substance shows absorbance is its identity, and extent of absorption at that wavelength is related with the amount of material present in the sample. Therefore, here in absorption spectroscopy, wavelength of absorption is the identity of material, and we may use this for qualitative analysis. And here, extent of absorption at that wavelength is related with a quantitative analysis. Therefore, here wavelength of absorption is the identity and extent of absorption is related with the amount of material. Therefore, example of this type is the ultraviolet visible spectroscopy or spectrophotometry. Therefore, in ultraviolet visible spectroscopy, we measure the concentration of molecular species, and it is a molecular absorption spectroscopy. Therefore, molecular absorption spectroscopy is subdivided into two types depending upon the nature of sample. If sample is molecule, then technique is called as molecular absorption spectroscopy. When example is UV visible spectroscopy. Second thing, when the sample is atom, then it is called as atomic absorption spectroscopy. In atomic absorption spectroscopy, the atomic species are irradiated with electromagnetic radiation. The wavelength at which that atomic species absorbs electromagnetic radiation is its identity, and also the extent of absorption is related with the amount of material. The example of this type is name itself, that is a atomic absorption spectroscopy or spectrophotometry. Therefore, absorption spectroscopy is divided into molecular absorption spectroscopy and atomic absorption spectroscopy. Similarly, when sample is irradiated with electromagnetic radiation, in emission spectroscopy, sample is irradiated with electromagnetic radiation. Then sample undergo electronic transition and it goes into the excited state. When this sample comes back to ground state, that emits a radiation. The wavelength at which emission occurs is the identity of the substance, and the amount of intensity liberated or given at that wavelength is related with the amount of material. Therefore, in emission spectroscopy, the wavelength of emission is the identity. That means we can use this for qualitative analysis. Similarly, the intensity of emitted radiation related to a quantitative analysis or a amount of material. Quantitative analysis or amount of material. Therefore, in emission spectroscopy, wavelength of emission is the identity and intensity of emission is related with the amount of material. Similarly to similar to absorption spectroscopy, emission spectroscopy is also divided into two types based upon the sample. If sample is molecule, then it is called as molecular emission spectroscopy. The example of this type is a fluorescence, molecular fluorescence spectroscopy. Molecular fluorescence spectroscopy. Here, if sample is atoms or atomic species, then it is called as a atomic fluorescence spectroscopy or spectrophotometry. Therefore, absorption and emission are the two main types of spectroscopy. Each spectroscopic technique is further divided into another type based upon the sample type. that is molecular absorption spectroscopy, atomic absorption spectroscopy, molecular emission spectroscopy and atomic emission spectroscopy. Therefore, basically spectroscopy is classified into 4 types. Student, now we discuss the terminology related to absorption spectrophotometry or absorption spectroscopy. First term is a radiant energy. Radiant energy. Radiant energy. Radiant energy is the energy transmitted in a beam of electromagnetic radiation or a wave of electromagnetic radiation. We know that light has a corpuscular nature, that is a particle and wave nature. Therefore, here the particles, that is called as photons, and here radiant energy means the photon energy which is carried in that wave. Therefore, the energy of photons in the wave is the radiant energy of the wave. Therefore, radiant energy, it is a energy transmitted in a beam of electromagnetic radiation. Actually, it is a energy of photons or photons of specific energy transmitted through beam of electromagnetic radiation. Second terminology is a radiant power. A radiant power, it is denoted by P. It is also known as intensity. Radiant power or intensity. Radiant power is the rate. Radiant power is the rate with which the energy is transmitted in a beam of electromagnetic radiation. Radiant energy is a rate with which radiant power or radiant energy is transmitted in a beam of electromagnetic radiation. Radiant energy is known as intensity. Energy is known as intensity of radiation, and it is measured in watt. That is a unit of radiant energy or unit of intensity or a radiant power. Third terminology, that is a transmittance. Transmittance denoted by capital letter T. Transmittance is the ratio ratio of radiant power transmitted through the sample to the radiant power incident upon sample. Therefore, here transmittance T is equal to P upon P0, where P is the radiant power which is transmitted through the sample and P0 is the radiant power falling or incident upon sample. In order to distinguish transmittance and absorbance, generally transmittance is expressed in percentage, and then percent transmittance is equal to P upon P0 into 100. Here, transmittance is the ratio of radiant power transmitted through the sample to radiant power incident upon sample. This ratio is always less than 1. Therefore, we can say that transmittance is the fraction of light transmitted through the sample. This ratio is called as transmittance. Student, the next term is a absorbance. Absorbance that have great importance in absorption spectroscopy. Therefore, fourth term is a absorbance. It is denoted by capital letter A. Absorbance is the negative logarithm of transmittance to the base 10. That means A is equal to minus log T to the base 10. Or we can write A is equal to log of 1 upon T to the base 10. That means here absorbance is the logarithm of reciprocal of transmittance to the base 10. According to this equation, absorbance is the logarithm of reciprocal of transmittance to the base 10. Therefore, absorbance is a negative logarithm of transmittance. Next term is a absorptivity. Number 5 is absorptivity. It is denoted by small letter a. Absorptivity is the ratio of absorbance of a solution to the product of path length in centimeter and concentration in grams per liter of the sample. Therefore, here small a, absorptivity, it is also called as extinction coefficient. A is equal to here absorbance divided by B in centimeter into C in grams per liter. When concentration is in grams per liter, then it is called as absorptivity, and it has a unit from this equation. Unit of absorptivity is liter per gram per centimeter. Therefore, here absorptivity have a unit liter per gram per centimeter. Next parameter is a molar absorptivity. Molar absorptivity, and it is denoted by letter epsilon. It is also called as molar extinction coefficient. Therefore, molar absorptivity is the ratio of absorbance of a solution to the product of path length in centimeter and concentration in moles per liter of the sample. Therefore, here when we multiply this A with molecular weight, then we have A changes to epsilon. Therefore, here in this case epsilon is equal to absorbance upon path length in centimeter in concentration into concentration in moles per liter. Therefore, here this is called as molar absorptivity, and unit of epsilon is again here concentration is gets changed in moles per liter. Therefore, it is liter per mole per centimeter. Liter per mole per centimeter. Therefore, the extinction coefficient when multiplied by molecular weight, then it becomes a molecular or molar extinction coefficient or molar absorptivity. Molar absorptivity is the product of absorptivity into molecular weight. But molar absorptivity can be defined as molar absorptivity is the ratio of absorbance of a solution to the product of path length in centimeter and concentration in moles per liter of the sample solution. Therefore, it is called as molar absorptivity. Next term is a path length. Path length, that is called as optical path. Optical path of the solution, and it is denoted by letter B. Path length or optical path is the internal diameter of a sample cell, and that is called as path length. Therefore, here sample cell is in this form. Therefore, this internal diameter of this tube is called as path length. Therefore, path length, that is the internal diameter or optical path of the solution. Student, these are the different terminology which we have to use in absorption spectroscopy or absorption spectrophotometry. Now, the homework or home assignment. Number 1, what is spectroscopy or what is analytical spectroscopy? That is a spectroscopy useful for qualitative and quantitative analysis. Second one, give the types of spectroscopy on the basis of mode of measurement and sample type. Number 3, define and explain the following terms. Explain the following terms. Number 1 is radiant power, radiant energy. Second one, radiant power. Then transmittance, absorbance, absorptivity, molar absorptivity, and path length. Student, with this we stop here. I wish you all the best. Keep learning. Happy learning.